Hello everyone, welcome to the new series. In this series, we learn some mathematical concepts that are useful for physics. If we learn the mathematical concepts before going into the physics concepts, then it will be very easy to understand the physics concepts. And in the definitions of physics concepts as well as in the derivations, we mostly use the mathematical steps. So if you see the new terms or new mathematical steps, you will get some confusion. So to avoid that, first we learn the mathematical concepts. Then once we are comfortable with the mathematical concept, then we go into the physics concepts. In this series, the first topic that we are going to discuss is the trigonometry. The moment the most of the students hear the term, the trigonometry, they think that this topic is only for the bright students or the top students. They think that they only can understand the concepts of trigonometry. But the truth is, everyone can understand trigonometry if you learn it in a proper way. The reason for the students believing the trigonometry is difficult is that you might have seen some funny videos or the movie dialogues like why should we learn trigonometry when we are not going to use them in the real life. But the truth is, we use the trigonometric ideas in daily life, but the thing is we don't realize. So in this series, we learn the trigonometric concepts in a simple way without any confusion. So let us start with the image. You can see on the screen. So you can see that there are three workers like construction worker, a carpenter and a welder. While doing their work, they'll be using the trigonometric ideas. For example, if they are constructing a staircase or a triangular frame, they measure the sides. That is the trigonometric. Trigonometry means trigono, three sides. Metry means measurement, measuring three sides of a triangle, that is called trigonometry. The same thing they are also doing, but the thing is they are not using the term like sine theta, cos theta or tan theta. That is what they are saying. We may not know sine theta, cos theta or tan theta, but our work does. Let me share an incident that I have observed recently. So a construction of a house was going on nearby my house, and I was observing one day. So for that house, the slab was already laid and the wall was constructed, and they are going to construct the stairs. So for that, a construction worker, he took a piece of chalk and a scale and a measuring tape, and he was measuring so precisely so that the steps that they are going to construct, they match exactly with the height of the slab. So he has drawn initially a line with some slope, and then the measured steps, the proper number of measurements for the steps, and then the height of the steps, initially they are matching up to the half of the height of the slab. And he reversed the direction, and again he has drawn the remaining half of the steps. So if you observe this diagram, it may look very simple, but what he has done is the measurements of the sides of a triangle. So if you observe properly, you can see two triangles here. So one is at the lower half of the wall, and the other one is at the higher half of the wall. So for understanding the trigonometric concepts, we take the same example. That is, a person is climbing a staircase. So we take the same example of a person who is climbing the staircase. So here you can see that the person is moving along a line which is having some slope with the horizontal. So we draw two lines. One is exactly horizontal, and the other line is matching with the direction of the motion. Normally a person is climbing a staircase. We think that the person is moving in the upward direction, but actually he is not only moving in the upward direction, he is also moving in the forward direction. That means his motion, it consists of two types of direction. One is in the upward, the other one is in the forward. We take the same figure to understand the trigonometric concepts. So here if you observe the two lines, one is the horizontal, the other line is having some slope with the horizontal line. Now if you observe the two lines, they are fixed at one point, that is here, and the second line, it is rotated through some amount from the first line. This rotation of the second line with respect to the first line, it is called the angle. And this is the first physical quantity that is related to the trigonometry that we are going to discuss now. So what is the definition of angle? The angle is defined as with the amount of turning or rotation of a line or a surface, okay, from a fixed line or a reference line or a fixed surface or a reference surface. How do we measure the angle theta? So for that, you take two lines. Okay, one is the black line, the second one is the red line. They are coinciding exactly with each other. And when they are coinciding, there is no angle between the two lines, then it is said to be 0. Now, if it is making one full turn, that is, if it is rotating completely and coming back to its initial position, then it is said to be 360 degrees. And if we are dividing the complete rotation into 360 part, then one part is called 1 degree. So here, when a line makes a full turn and comes back to its initial point or starting point, we call that 360 degrees. Then how do we define 1 degree? So if full rotation, if it is divided into 360 parts, then one part is called 1 degree. Why 360? So you may get the doubt like, why it is 360? Why not 100, 200 or 300? So for this, there are two reasons. The first one is the historical reason. The ancient Babylonians, they used the number 360 first, and they used to follow the number system that based on the number 60. Okay, that is also called sexagesimal number system, and they also calculated the number of days in a year, okay, that is 360, and we are still following the same 360. And the second reason is the mathematical reason, and if you take the 360, there are so many factors for 360. Okay, like 1, 2, 3, 4, 5, 6, 8, 9, like that. So that means you can divide the circle into these many equal number of parts. Something like if you take 2, so we can divide the circle into 2 parts. They are equal in size. Otherwise, if you take the number 3, that is the factor 3, so you can divide the circle into 3 parts. They are equal in size. The same way, okay, 4, 5, 6, and then the 8, and so on. So you can test for the other numbers, the other factors like 9, 10, 12. Okay, so finally 360. So if you are dividing the circle into 360 part, one part is called 1 degree. The next one is the angle is also measured in terms of radians. So radian is another way of measuring the angles, and it uses the circle's own length, that is the radius, to define the angle. So here you consider a circle of radius r. Now you take a line, okay, whose length is equal to the radius of the circle. Now you bend the line in the form of an arc, okay, that fits exactly on the circumference of the circle. Now you place the arc on the circumference of the circle, and now you draw a line from the center to the other end of the arc. Now if you observe, okay, the radius of the circle, that is r, and the length of the second line that is drawn is also r, and the length of the arc, that is also r. And this arc, it is making some angle at the center, that is called 1 radian. Now we check like how many radians we can fit inside the circle. Now we start with, okay, the first one. Okay, this is the first radian, and this is the second radian, and this is the third radian. So after placing 3 radians, you can see that there is a small space that is remaining to complete 180 degrees. That means the total 180 degrees, that is equal to 3 radians plus some fractional number times the radian. Now the mathematicians, they calculated, okay, this fractional value that is nearly equal to 0.14 radian. So therefore the total value is 3.14 radians. And we know that, okay, this value 3.14 is nearly equal to pi. Therefore 180 degrees is equal to pi radians. Now we fill the remaining space with the radians. Then this is the 4th radian, 5th radian, and then the 6th radian. So if you combine this gap, then the total angle 360 degrees, that is equal to 2 pi radians. This gives the relation between the radians and degrees. They are the different units used for the measuring the same physical quantity, that is angle. So now we go to the topic trigonometric ratios. So for this we go back to the same example, that is a right angle triangle is drawn from person climbing staircase. That is, there are two lines, they are making an angle theta. And here at this corner, okay, the two lines, they are making exactly 90 degrees angle. So whenever I mention right angle triangle, that means you take, okay, the angle at this corner as 90 degrees. And now we name the sides of the triangle. Okay, the side which is adjacent to the angle theta, that is called adjacent side. Just say this is denoted by A. You note down, this is the adjacent side. And the side which is opposite to the angle theta, that is called opposite side, and it is denoted by O. Please note down opposite side. And the third side is called hypotenuse, that is denoted by H. It is mentioned ratios, trigonometric ratios. So here that means the ratios of the sides. There are three sides here. Then how many ratios we can get? So if we have the numbers like 1, 2, 3. So then how many ratios we can write from these three numbers? 1 by 2, 2 by 3, okay, and then 3 by 1. So if you reverse this one, so it will be 2 by 1, okay, 3 by 2, and then 1 by 3. So totally we get 6 ratios. Same way, okay, here we can write 6 ratios, that is O by H, that is opposite side by hypotenuse, and then A by H, that is adjacent side by hypotenuse, and then opposite side by adjacent side. Now you reverse the ratios, that is H by O and H by A and O by A. Okay, these are the 6 ratios that we can write from the simple right angle triangle. Now we are going to check how these ratios depend on the angle theta. So now we take a simple right angle triangle with the angle 45 degrees. Now by keeping the 45 degrees angle constant, we vary the size of the triangle and we check what happens to the trigonometric ratios. Now let us draw the right angle triangle. First a horizontal line and next a line, okay, which is making an angle 45 degrees with the horizontal line. Now to complete the triangle, we need to draw the vertical line on the third side. The second line is taken lengthy, okay, because if you want to double the size of the triangle, it will be helpful. So here we draw the third line, that is exactly the 90 degrees line. So here the angle of the triangle is 45 degrees. So the same triangle can also be assumed like you have taken a perfect square of side A, that means all the sides are equal, the length is A. Now if you join two corners, then it forms a diagonal. This diagonal line will be making exactly 45 degrees with the horizontal side as well as with the vertical side. Now, so whenever you draw a triangle, a right angle triangle with 45 degrees, then these two sides, that if you observe here, these two sides are exactly equal. So whenever you draw a right angle triangle with 45 degrees, then these two sides, that is the adjacent side and the opposite sides, they will have the same lengths. To make the calculation easy, so I've taken 1 unit and 1 unit for the adjacent side and the opposite sides. Therefore, from these lengths, we can find out the hypotenuse values by using the Pythagoras theorem. So by using Pythagoras theorem, what can we write here? The hypotenuse square is equal to the adjacent side square plus the opposite side square. Okay, that is 1 plus 1. That is 1 square plus 1 square. That is 1 plus 1. That gives 2. Therefore, the hypotenuse value is square root of root 2. So this value will be root 2 units. So we have the values of adjacent side, opposite side, and then the hypotenuse. Okay, now we find the ratios. Now for the first ratio, that is O by H, it will be 1 unit divided by root 2 units, that is 1 by root 2. Now for the second ratio, that is A by H, it will be again 1 by root 2. Now for the third ratio, that is O by A, that is 1. Now for the remaining 3 ratios, just you need to reverse it. That is root 2, this will be root 2, and this will be, okay, these are the values when the right angle triangle with the 45 degrees angle, if it is having the sides 1 unit and 1 unit, and the hypotenuse is root 2. Now I increase the size of the triangle, I just double the adjacent side. So instead of 1 unit, I take 2 units. Okay, then what happens to the opposite side? It will also be of 2 units. Whenever you take a right angle triangle with the angle 45 degrees, then the adjacent side and the opposite sides will always be the same. Therefore, this will also be 2 units. Then what is the value of hypotenuse? That is 2 square plus 2 square. Okay, that is equal to 4 plus 4, which gives 8. Therefore, h is equal to square root of 8. This can also be written as 2 root 2. Okay, therefore, the third side, that is 2 root 2. So now we have the values of adjacent side, that is 2 units, opposite side, that is also 2 units. Then the hypotenuse is 2 root 2. Now we take the same ratios. So here if I take the ratio, that is O by H, that is 2 by 2 root 2, it gives again 1 root 2. Okay. Now if I take the ratio A by H, that is 2 by 2 root 2, that gives the ratio 1 by root 2 again. Now if I take the ratio O by A, that gives 2 by 2, that is 1. And if you reverse the ratios, then you get the same values, root 2, root 2. So what you have observed here, when the size of the triangle is doubled, you get the same values for the ratios. And even if you increase, like if you triple it, and if you increase the size of the triangle to 10 times, whatever the size you take, if you maintain the angle 45 degrees constant, then the values of the trigonometric ratios will always be the same. Therefore, we can write, okay, if the angle of the right angle triangle is fixed, then the ratio of the sides of the triangle remains the same, whatever may be the size of the triangle. So is it same for the other angles? For example, say 60 degrees, 30 degrees. Now we check for the 60 degrees right angle triangle. So for that, okay, whenever you take the right angle triangle, you should have the values of the sides. Okay, to check for the right angle triangle with the 60 degrees angle, we take an equilateral triangle. That means all the angles are equal and all the sides are also equal. That is 60 degrees, and then all the sides, they are equal. So we can take the same values for all the 3 sides. And from this equilateral triangle, okay, we take half of the triangle. Okay. So therefore, if I choose, for example, these sides are like 2 units. Now if I take half of the equilateral triangle, then this half will be 1 unit. Okay, this half will be 1 unit, and this side, it remains the same, that is 2 units. Now if I just separate this triangle, I take it separately. So this is 1 unit and this is 2 units. Now I take this triangle and I check the ratio values. If this side is of 1 unit and this side will be of 2 units. So here you need to remember one point, that when you draw a right angle triangle with one of the angle is 60 degrees, then okay, one side, that is the adjacent side, will always be 1 unit. Then its hypotenuse will be twice that of the adjacent side. It is same. It is always same. Okay, therefore the adjacent side can be taken as 1 unit. Then the hypotenuse will be of 2 units. And what about the opposite side? We can find out by using the Pythagoras theorem. Okay, that is O square is equal to H square minus A square. What is H square? That is 2 square minus A square, that is 1. Okay, that is 4 minus 1, it gives 3. So from this, O is equal to square root of 3. So therefore the opposite side will be of root 3 units. Now we check the ratios. What is the ratios? Okay, O by H, that is root 3 by 2. Next one, A by H, that is 1 by 2. Next one is O by A, that is root 3. Now you reverse the ratios to get the other 3. H by O, that is root 2 by root 3. H by A, that is 2. And A by O, that is 1 by root 3. Now I double the size of the triangle. For that, I double the adjacent side of the right angle triangle, that is instead of 1 unit, I take it as 2 units. Now on the other side, okay, that is the hypotenuse, instead of 2 units, it will be 4 units. Is it? Then only I'll get a complete triangle. So here, the adjacent side, that is A is equal to 2 units, and the hypotenuse, it will be 4 units. Now we find out the opposite side by using the Pythagoras theorem. That is h square minus a square. H square is 4 square minus a square, that is 2 square. That gives 16 minus 4, that is 12. Therefore, O is equal to square root of 12. So this can be written as square root of 4 into 3, that is 2 root 3. So we get 2 root 3. Now we take the ratio values in the same way. So what is the first ratio? That is O by H. So this is the O by H, that is 2 root 3 divided by 4, that is root 3 by 2. Root 3 by 2. Next one, A by H, that is 2 by 4. After simplification, it is 1 by 2. Next one is O by A, that is 2 root 3 divided by 2, that is again root 3. Now for getting the remaining 3 ratios, we need to reverse the previous ratios. Okay, that gives again the same value, 2 by root 3, and then again 2. So we got the same values again. Just we mentioned the final conclusion here. If the angle of the right angle triangle is fixed, then the ratios of the sides of the triangle remains the same, whatever may be the size of the triangle. What about the one more angle? That is 30 degrees. Okay, for 30 degrees triangle, just I'll show you the triangle. You just try by yourself. So here, you just take the same triangle and then you rotate it in the clockwise direction. So here, this angle will be 30 degrees. This angle will be 30 degrees. For the 60 degrees right angle triangle, if the adjacent side is 1, then its hypotenuse will be 2 units. And we have found the opposite side, that is root 3. Now these values are same for the triangle with the 30 degrees, but the sides are changed. For 30 degrees right angle triangle, so here the adjacent side is of root 3 units and the opposite side is of 1 unit, and the hypotenuse will be the same, that is 2 units. You check the ratios once and then you double the size of the right angle triangle and then you check the ratios one more time. Finally, you will come to the same conclusion that if you maintain the same angle for the given right angle triangle, then its trigonometric ratio values will always remain the same. You just check this one by yourself. Now, till now what we have done is, like, we have taken a right angle triangle and which is of angle theta, and we have named the sides, that is the adjacent side A, opposite side O, and the hypotenuse H. And with respect to the angle theta, we have taken the ratios, that is O by H, A by H, O by A, and H by O, H by A, and A by O. These are the 6 ratios. And we have already studied, okay, how these ratios vary with respect to the angle theta. And we have seen that when you maintain the angle theta fixed, then the values of the ratios, the trigonometric ratios, will remain the same, whatever may be the size of the triangle. Now, therefore, if you change the angle of the right angle triangle, so what happens? The values of the ratios will also be changing. That means, okay, these ratios, they purely depend on the angle theta, that is the angle of the right angle triangle. Therefore, we can say that these ratios are functions of theta. So therefore, we can write down, okay, the first ratio is f1 of theta, the second ratio is f2 of theta. Okay, like that we can write the functions. That means, okay, these ratios are different functions of the angle theta. For the chosen angle theta, okay, these ratios will have different values, but they remain the same as long as theta is fixed. Now, instead of writing f1, f2, f3, okay, we write down the universally accepted names for these functions. That is, instead of f1 of theta, you write down sine theta. Therefore, the sine theta is defined as, okay, the ratio of opposite side by hypotenuse. The same way we can give the names, or we can write the universally accepted names for the other ratios also. Okay, that is cos theta for a by h and tan theta for o by a. That means cos theta is defined as adjacent side by hypotenuse, and the tan theta is defined as opposite side by adjacent side. And the reverse the ratios, okay, for that also we have the names, that is cosecant theta or cosec theta, that is h by o, and secant theta or sec theta, that is h by a, and finally, okay, cot theta, that is a by o. Now we go for the table. That means we write the sin theta, cos theta and tan theta values for standard angles. So here we start with the 45 degrees. For 45 degrees, when you draw a right angle triangle, okay, we know that, okay, this angle is the 45 degrees, and then this is 90 degrees, and these sides, okay, the adjacent side and the opposite side, we just show with A and O. Okay, these sides will have the same lengths. For making the calculation simple, so we take 1 unit and 1 unit. Then automatically by using Pythagoras theorem, we get the value √2. Now we can write down what is sin 45. What is sin 45? Opposite side by hypotenuse. That is 1 by √2. And then cos 45, that is adjacent side by hypotenuse. Okay, this value is the hypotenuse. That is 1 by √2. Next one, tan theta or tan 45, that is opposite side by adjacent side, that is 1. Now we go for the 60 degrees. For 60 degrees, we take the triangle, that is this angle is 60 degrees. And this is, since it is a right angle triangle, this must be 90 degrees. And we know that in the case of a right angle triangle with the angle 60 degrees, if the adjacent side, if it is 1 unit, then the hypotenuse will be of 2 units. It is exactly double. Okay, this will be 2 units. Then by using Pythagoras theorem, we can find out the opposite side. Okay, that will be √3. Okay, therefore, what is the value? Then for sin 60 is √3 by 2, and cos 60 is 1 by 2, and tan 60 is √3. Now we just rotate the same triangle with 60 degrees, then we get this one. So here, okay, if you just rotate the same triangle in the clockwise direction, okay, what we get? Okay, we get here 30 degrees, okay, with respect to which we are finding the ratios. Then this √3 will come here, okay, and then the hypotenuse will be 2. The opposite side will be 1. So now this is the opposite side, and this is the adjacent side, and this is the hypotenuse. Now we write down for sin 30, that is opposite side by hypotenuse, that is 1 by 2. And for cos 30, so cos 30 is equal to adjacent side by hypotenuse, that is √3 by 2. And then the tan 30, that is opposite side by adjacent side, that is 1 by √3. So we have calculated the values of sin theta, cos theta and tan theta for the angles 30 degrees, 45 degrees and 60 degrees. So these are the values. Now we go for the 0 degrees first and then the 90 degrees. So for 0 degrees, okay, we need to take 2 lines. Normally for drawing a right angle triangle, the 2 lines must be making some angle theta. So if the angle between these 2 lines is theta, okay, then this, the vertical line that is drawn, okay, to complete the right angle triangle, it will be the opposite side. And then, okay, this side will be the adjacent side. And the red line, okay, it indicates the hypotenuse of the right angle triangle. Okay, now when the angle theta is equal to 0, then both the lines, they coincide with each other. So in that case, okay, the theta is equal to 0, and the opposite side, O, it becomes completely 0 because there is no line, okay, to join the 2 lines. Now the adjacent side and the hypotenuse, they become equal in length. For making the calculations easy, we take, okay, both the lengths is equal to 1 unit. Okay, now if we find out the sin theta, that is sin 0 is equal to O by h. O is equal to 0 and H is equal to 1. Therefore, 0 by 1, okay, that is equal to 0. And next one, cos 0, that is A by H. So A is equal to 1 and H is also equal to 1, that is 1 by 1, okay, that is equal to 1. And tan 0, that is opposite side by adjacent side. Opposite side is 0 and the adjacent side is 1. That is 0 by 1 is again 0. So therefore, these values are 0, 1 and 0. And now we go for the 90 degrees case. For that we draw two lines. They are making exactly 90 degrees. That means they are perpendicular to each other. So this angle is 90 degrees. Now, for example, if we want to join the two lines to complete the right angle triangle, that is not possible here. So we take the third line and we assume that this third line will meet the vertical line at infinity to complete the right angle triangle. That is just assumption. So in that case, okay, here the adjacent side, okay, this is the adjacent side and the opposite side is this one and the hypotenuse is this one. And hypotenuse and opposite side, okay, H and O, okay, they are equal to each other in length and they are meeting at infinity. Okay, therefore we take infinity. Okay, for the adjacent side we take 1 unit to make the calculations easy. So this is A is equal to 1 unit. Okay. Now we write down the values for sine 90. Sine 90 is equal to O by H. O is going to infinity and H is also going to infinity. That means at the infinite distance, both the opposite side and the hypotenuse will have the same length. Therefore, O by H is equal to 1. The next one is the cos 90. The cos 90, that is equal to A by H. A is 1 and H is infinity. That is 1 by infinity, that is equal to 0. And the third one, okay, that is tan 90. Tan 90 is equal to O by A. So O is going to infinity and A is equal to 1. So infinity by 1, that is truly speaking, okay, infinity. Technically speaking, it is infinity, but in the mathematical point of view, that is not defined. Therefore, it should be undefined. So this quantity is not defined. So we found the values of sine theta, cos theta and tan theta for the 90 degrees, that is 1, 0 and not defined. Now to get the values of cosecant theta, secant theta and cot theta, we need to reverse the values of sine theta, cos theta and tan theta. Just I mentioned the expressions here. For cosecant theta, you need to reverse the values of sine theta, that is 1 by sine theta. And for secant theta, you need to reverse the values of cos theta, that is 1 by cos theta. And for cot theta, you need to reverse the values of tan theta, that is 1 by tan theta. And if you reverse these values, you will get the values, okay, that is shown here. So with this, okay, we have filled all the values of trigonometric ratios for the standard angles. And in the second part, we will see the complementary angles and then ASTC rules. And finally, we'll see a few examples to understand the applications of the trigonometry.